Right, guys. So today we are going to cover the configuring vSphere high availability in your environment. We are going to understand about what is the prerequisites and to identify the requirement for building a cluster and enabling the vSphere high availability. Okay. So when we do want to configure the vSphere HA high availability in clustering environment, so the first thing, my host should be configured at least one management network, either static or by DHCP. And if it is from DHCP, it should be stable IP. Your host should not change the IP address. IP should be persist. So normally people don't use through DHCP. They always prefer to give a static IP address. All hosts must have at least one management network in common. When I say common, management VLAN ID should be common and they should talk with each other. For, for a virtual machine level of monitoring, VM tools must be installed in every virtual machine. And vSphere HA cluster that contains 6.x later can be used to enable virtual machine component protection. That we talked yesterday, like storage failure. To protect from underlying storage failure for particular host, this feature have been introduced from vSphere 6.x onwards. When I say 6.x, these are the versions. You must not need exceed the maximum configuration limit for that particular cluster that I yesterday told you also. Like we can go ahead and we can check the config max guide on VMware. This is publicly available, right? So how we do enable the vSphere HA feature? So for that, you just go to your cluster, right? Pane configure vSphere availability and turn on this button from gray to green. Once you will turn on this option from gray to green, so these are the default setting. You will get with cluster like host failure response, restart the VM. If any of the host will got failure, it will restart the VM. Response for host isolation by default disable. Here you will get an option power of restart. Data store permanent device loss. Again, default setting is this data store APD. APD stand for this. This is PDL and APD X. I think it is append device or something. There is a full form. Yesterday we have seen that APD and PDL. These are two situations, right? To avoid the failure, let me check. Yes, it should be here. All path down. All right. APD stand for all path down. So these are the by default settings. If we want to enable VM level of monitoring, when we say VM level of monitoring, there is two options you will get: VM and application monitoring. So when we say VM monitoring, it means that if there is no heartbeat from respective VM to your host, then it will restart. Same way for it will restart the application. Okay, so these are the options for available when APD, in same way for PDL. Okay, so we will get different options in each section that we'll talk while we're doing the lab. Same way for monitoring, as I said, VM monitoring and VM and application monitoring. Normally people keep it disabled by default, but if in case they want little bit deeper of monitoring, kind of VM monitoring, VM is not responding to ESXi host on the heartbeat network. So in case that will restart, and when I say VM and app, then it will do VM monitoring and application monitoring also. It means that if there is any virtual machine, and this is my ESXi host, there is a heartbeat between your host. This heartbeat channel is different than your HA cluster, right? So if you'll find VM is not responding for 3 consecutive heartbeat, it will restart, but on same host. Same way, particular application is not responding through heartbeat, then it will restart the VM on the same host. All right. Heartbeat data store. when we say heartbeat data store, like again, it is not a possible scenario in vSAN, it is on remote data store. So data stores are our secondary channel of heartbeat between your ESXi hosts. Like these are my data stores. So there is a heartbeat channel through data store as well. So recommendation is to keep the redundant data store for maintaining the heartbeat. Okay, so by default it will select some data store, but later on we can identify the data stores manually for the heartbeat channel. Under admission control is the important factor while we are designing our cluster. So when we say admission control means is the capacity on the cluster you are reserving for maintaining the failure. So for example, if we are using a 4-node cluster, and out of these 4 nodes, from each host, participating resource is, just for example, 10 GB and 2 gigahertz of CPU. All right. Then my total cluster will have 40 GB and 8 gigahertz of CPU. There is no relation for storage. Storage is shared always. Okay. It's more related to your CPU and memory. So the total resource I got it. But in this cluster, if I will provision this whole resource, like I have just utilizing all 40 GB VM 8 gigahertz of CPU, that's in use mode actually. So in case any of the host will get failure and my VM need to restart to another host, if they will find the CPU and memory, then only they will restart. If they will not found CPU and memory, they will not restart. That's why in cluster, we configure some resource reservation. When we say resource reservation, it means that from that cluster, we are reserving some of the capacity that will handle the failover. Like in this example, we could say we are maintaining in admission control 1 host. So it means that is equal to the capacity of 1 host we are reserving for maintaining the failure. 1 host capacity reserving does not mean that 1 host is idle. It means that capacity equivalent to 1 host. So it means that my 1 host capacity is reserved. It means 10 GB of RAM and 2 gigahertz CPU is being reserved. That will not be available for you to simply provisioning the VMs in cluster. Only you will get for provisioning 30 GB and 6 gigahertz of CPU. 30 GB of RAM, 6 gigahertz CPU. All right. So we have to design and plan the failover. Like out of these 4, if we are maintaining 1 host reserve capacity, it means that we are reserving the 25% capacity as per this example. All right. So maybe you will have more nodes in the cluster, maybe 8 nodes. In this 8 node, if you maintain 1 host failure, then this value will go 12.5%. All right. Out of 8 hosts, I am maintaining 1 host failure. It means that in percentage, it is 12.5. If again, I will increase 16, like 16 node cluster, I am maintaining only 1 host failure. It means that this capacity will go somewhere 6.25. Correct? So it's all being designed and decided by our solution team, whatever capacity they want to reserve in admission control. All right. Are we clear on it? Yes, no?
Sir, I have doubt. I get confused on this.
No problem. देखो, simple thing. You 4 people working in some customer support, I say one okay, let's say in another way. You have 4 boxes where you are putting some balls. Simply some balls are there. Okay. you are assuming near in future, you may have a failure of any of the box. So how you will maintain these balls there? You need some resources, correct? You need some other boxes so that I can put these VMs to, I can put these balls to another box. Same way, if we have a 4 node cluster, out of 4 node cluster, whatever capacity we have available for maintaining the CPU and memory resources for the VM, I should never provision the whole. I should keep at least one host for reservation, one host capacity, I would say, for reservation, so that near in future, if any failure will occur, the VMs can move to another hosts because we have the sufficient capacity available. That's why we have reserve. So this reservation is my admission control. Like if I would say host failure cluster tolerate 1, it means that it can tolerate. How it can tolerate? Because it is going to reserve the resources of 2 hosts. Another example, if I would say I have a 8 node cluster, 4, 4, 4. Out of these 8 nodes, I want to maintain 2 host failure. So it means that if 2 hosts will parallelly failure, then running VMs on these 2 hosts will be migrated to rest of the host. But for for keep them power on working and all, they need some CPU and memory. How this CPU memory will come? From this reserve space, right? Because we have maintained 2 hosts as an admission control. Clear?
Yes, sir.
All right. Don't feel hesitate to ask the question. All right. Good to hear you. So same way as I said, as per our plan and design team, whatever cluster we are designated by default, each cluster have one host capacity reserve. All right. But if we want to make it less than one host, then there would be a chance. Like for example, if there is 3 node cluster and I have reserved 33% capacity, so it means that I am reserving the capacity of one host for maintaining the failure. But if I will reduce this capacity from here, as per this example, 33, 33, 33, so one host capacity I have reserved, right? If I will reduce it, like I have reduced it 10% for an example. So it means that from total resource of this cluster, I have only reserved the 10% capacity. But if in case tomorrow some failure will happen, some hosts will get failed in this cluster, there is no guarantee the VM will be power on this on the rest of hosts, because you have reserved less than actual capacity required. All right. Until unless there is no sufficient reserve capacity available, we can't guarantee that it will maintain at least one host failure. So again, as I said, it's all depend upon environment to environment, how many hosts they wants to maintain as a FT. But the host resource you will reserve for the failover, that capacity will not be available for provisioning. That's a reserve space. Okay. So performance degradations VM tolerate. Percentage of performance degradation VM clusters are allowed to tolerate during a failure. If it's a 0%, raise a warning to insufficient failover. But if I would say it's okay, 100%, it means that I have sufficient capacity. I am good to, this cluster is good to failover the VMs to another host if in case any host got down. All right. So here, here is some example of admission control using the cluster resource percentage. All right. So I just give an example. What I just described you, this is the same example again. So like total cluster capacity have 18 gigahertz of CPU, 24 GB of RAM. Out of this, if I will say maintain one host failure. In this scenario, maintaining one host failure means reserving out of 100% resource, reserving approximately 33 something, it is goes to 100%, right? So if I will say one host reservation, it means that I am reserving this capacity. How much? I am reserving this capacity. Okay. Then current CPU failover capacity is only 61%. All right. Current memory failover capacity is as per the memory reservation. The capacity is available for now. Sorry, this is a different example. So here the reservation is not cluster level. Reservation is not on VM level. So when we do fix some resource reservation for virtual machines, it means that we have to reduce that capacity by default from the cluster because those are being reserved by the virtual machine. So now for the cluster, I have total capacity, CPU perspective this and memory perspective this, because all these resources being, don't get confused, this reservation, this is the cluster and host level reservation. Cluster have booked some of the space in advance for maintaining the failover, but here reservation is on virtual machine level. We can do some fixed resources to VMs, then we have to reduce the reserved resources from the actual capacity of CPU and memory. So out of it, if out of 18, 7 is reserved, then I have 61% as in my CPU and 75%. So this is my 100% capacity. What is 100%? 18 gigahertz, 24 gigahertz, right? But out of them, 7 have given to reserved to virtual machine level, and this GB memory, a 6 GB memory is reserved for all these virtual machines. So what I will say, when I will reduce this value from 18 to 6, the remaining percentage is 61%, and 24 minus, sorry, say 18 minus 7, 24 minus 6, it is 75. So now I would say in my cluster, actual resource is available now 61% and 75%. Right. So admission control using the slot. Slot क्या होता है? What is a slot? So a slot is a logical construct by sizing the CPU and memory. All right. So simply, like this is my cluster, what it will do, as per the available CPU and memory, it makes some slots. Slot is simply, it make a, like this is my cluster, it makes some logical space, and it say, I am assuming as minimum as one slot size is one second, I want to see that 32 MB one slot size. So by default, cluster creates the slot size like it is, I believe, 100 MB of RAM and 32 megahertz of CPU. This is one slot size. So what it will do, from the actual resource in the cluster, it will divide this value by 100 MB, total memory by 100 MB. Let us suppose I have this amount of MB RAM available in cluster. If I will assume one memory slot size will be 100 MB, so I will have 1000 slots for memory. And if I assume I have 33,000 megahertz of CPU divided by 32. It will go somewhere 90 or something or 900. So it will take the least value of this slot size. So it will divide the entire resource into slot size, and it will consider as minimum as size of your virtual machine going to place in these slots. But can we customize the slot size? Answer is yes. Slot is nothing, just a logical size that you are putting on the top of inside your cluster, that is telling you at least a VM will be placed in this space. So if we take this example, the slot size have been taken 2 gigahertz of CPU and 2 GB of memory. This is my one slot size. Okay. So if here you see each host have 6 gigahertz CPU, 8 GB RAM, 6 gigahertz CPU, 8 GB RAM, 6 gigahertz CPU, 8 GB RAM. Okay. So what slot size is here? CPU is 2 gigahertz, correct? And memory is again 2 GB. So if I will divide the value which is on my CPU, which is my host every place, so how many slots I will get? 3, 3 each, 3 each. All right. So the simple example is on each host with this size of machines, I can run 3 VMs. But if size is lesser, I can run more than that. Okay. So now cluster have total slots 9. Okay. Total slots 9. Now if you will say, sir, here I am running 1, 2, 3 virtual machines. All right. With this configuration, 2 gigahertz, 2 GB. I am running 1, 2, 3, 4 virtual machines here with same size, 2 gigahertz, 2 CPU. And I am also running 1, 2, 3 VMs with same size. So it means that now you are running 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 VMs total. Each with capacity 2 gigahertz, 2 GB. First question is, will it allow to run the 10 VMs? Answer is no. Because if you have defined the slot size, you cannot go beyond the slots value at all. Okay. Also, if now let's take an example of admission control. If you will say reservation, in reservation, you have put one host failure. So now you will be remaining only out of 9, you will be only remaining 6 slots for working, and 3 slots will reserve for maintaining the failover. All right. So if we want a failover, we should have the sufficient slot size should be available on the remaining hosts or on the remaining capacity that we have defined into the cluster. Now question is, sir, do we need to define the slot size manually? Answer is no. Your cluster will by default manipulate the calculation of CPU and memory, and there is the default size being cluster have been created, and it will take care of these all stuff. What you need to take care? You need to take care only like out of 3 node cluster,